Okay, so we're going to continue studying the fifth force, taking a deeper look. We actually measure it with our assessments. I'm going to show you here data from team development assessments, our most powerful tool for developing leaders and improving team performance and lowering risk. And we've measured hundreds of teams. In fact, I believe there's 1,500 been measured already. So some time ago, we built a benchmarking scale. We made a histogram of scores. Then we smoothed it, ran a curve through it. Then we divided it into 5 sections, and the reason is I think this is about the precision of the measurement. These are quintiles because there's 5. And so I'd like you to now show you the difference between a team that's benchmarking down here and a team that's benchmarking up here to connect the TDA scores with actual performance and risk. A bottom quintile team would be full of criticism. People would be miserable, full of conflict. People are fighting about everything. Full of isolation. Isolation's interesting. Being isolated makes us angry, so you see a lot of anger. No trust, as agreements are freely and willfully broken. Blind optimism replaces reality. No commitment to anything that matters. People are lethargic, disconnected. People living in drama states, particularly the victim. The victim says it's hopeless, and then having decided it's hopeless, decides there's nothing you can do and so does nothing. And there's no clear accountability or responsibility for anything. It's just a big mess. A top quintile team, in contrast, would be full of appreciation, which creates an atmosphere of mutual respect and open communications. High collaboration as people address the interests they share with each other. People feel happily included and relate authentically. Trustworthiness is very high and agreements are rigorously kept. Reality-based optimism replaces ignoring reality. People are 100% committed to things that matter to the team. People take responsibility. They don't tolerate victims or blamers. And everyone understands what they're responsible to do, what they're being held accountable for, either by themselves and others, and they do it. Wow, what a difference. So let's take another look at some other examples I'll show you later. When teams are permitted to exist in the bottom quintile, you blow up space shuttles, you build telescopes that don't work, you crash 747s, and you crash subway trains. I'll show you this. Teams that are in the top quintile have high profits. You can read a story about this and how NASA builds teams on page XIX in the introduction. A project called Stereo on page 54 that went from being almost canceled to being a model of managerial excellence. I'll talk later about an example from the Avionics Systems Division, building electronics to go back to the moon. They, over several years, took every team starting in the bottom quintile to every team in the top. And I'll show you how I created a high-performance context for the Hubble servicing mission, which was completely successful despite being much more difficult than the Hubble development. In 1986, I drove into my headquarters parking place to find people waiting for me. And as I got out of my car and walked to the elevator, they said, "Charlie, Charlie, Challenger's exploded." Well, the reason they told me this is that my division had built a small satellite that was on Challenger. It was called a Spartan. And, you wonder for a moment whether something we had done could have caused this to break loose out of its cradle, go through the cargo bay doors, which aren't very strong, and somehow killed the astronauts. Well, of course, we had nothing to do with it. As it turned out, it was a problem with the solid rocket motors. And I made the mistake that almost all technical people make. Very famous physicist and hero of mine, Richard Feynman, was on the failure review board, and he dipped a piece of the rubber material that was in the O-rings of the boosters into his ice water and showed that it stiffened. And so when I saw that, I said, "Oh, it's a technical error. They didn't do the math right. They got something that was not suited for low temperatures and launched anyway." Later, I read a book by Diane Vaughan, who was a member of that board, and she said the really interesting question was, why did they choose to launch when all the evidence suggested they should not? What she named was a term called normalization of deviance. What was going on at the time is there was enormous pressure to launch the shuttle on time. And in this environment, without noticing it, perception gradually changed to where the NASA management team required an ever more persuasive argument to delay a launch than to continue. And so this was the phenomenon. She said the sociological. Then she went on to say that it's very unfortunate that the sociological answer is the correct one because these forces are invisible and unacknowledged. And in today's language, I would say a flawed team social context put good people in a bad place. We had for sure a red quintile team like I've already shown you. Well, unfortunately, I didn't learn any lesson from this. And so in my 8th year as director of astrophysics, I took my people down to Kennedy Space Center to launch Hubble. And we got a perfectly good launch. Everything was fine. The telescope came out. It was deployed. All the systems worked. A few months later, we waited for our first image. This is a galaxy called M100 nearby. This is what we expected to see, something like this. By the way, this is an image from the repaired telescope. This is what we saw. What happened? Well, the failure review board studied this for a long time, and what we learned was there was a device, here's a picture of it, that's used to manufacture the mirror. It's called a null corrector, but it's not important. And the two mirrors in here were misspaced by a huge amount, made the mirror incorrectly. So the failure review board found the technical error again. This is a common recurrent pattern, and asked themselves why, since there were many other measurements with other devices other than this, why didn't the contractor stop and try and figure out what was causing the difficulties? Well, what was happening here was we had recurrent overruns. Hubble Space Telescope was originally supposed to be completed for $400 million. It overran 3 other times. When you have to go get that kind of money from the Congress and you look around for whose fault it is, it's very natural to blame the people who are doing the work, natural and inappropriate and unfortunate. So we were very hostile to the management of the contractor. And so they got into a mindset that they weren't going to work on any problem that didn't absolutely look real. And we had plenty of real technical problems to work on. So they rationalized the results. And you can read much more about this in the slide notes or in my book. Next thing they said was the failure review board knew that NASA had really smart people on its science working group who understood this whole phenomenon of spherical aberration that was such a common cause of difficulties with ground-based telescopes. And they wondered why those scientists had never tried to understand what was going on. They found then the contractor never told us. And this is the same problem with the red quintile teams. Communications break down, especially about difficult issues, because in this context, we would just simply rain criticism on the contractors. People get tired of it. Well, the failure review board chairman was an interesting man, and he reported to the Congress how we wasted 15 years and $2 billion and built a telescope that was useless. He said the root cause was a leadership failure, and I was the leader of the team. More interestingly, nobody ever blamed me for this because technical people did not understand the power of social context or even what leadership was about. So what's going on here? What kind of people do you think we had on the solid rocket motor, the engineering and management teams for the shuttle, or the people, what kind of people, technically able people or managers do you think we attracted to Hubble Space Telescope? The best in the world. So there's a lesson here. Individual abilities, which we all work so hard to develop, are trumped by the fifth force. I think if this work had been done today, the failure review board would have said it was a flawed team social context. We didn't have the terminology until much later when I did this work. Here's another one. This is really fascinating to me. Korean Airlines was crashing at 17 times international norms, but what fascinated me the most was this went on for 4 years. What mistake was everybody making that these things kept crashing? In fact, it got so bad, the president of Korea would not fly on Korean Airlines. What was going on to make this so bad, and why did it go on for so many years? Well, it's the same thing I just talked about a moment ago. Everyone thought it was about individuals' abilities, and they kept testing the Korean airline pilots. And of course, it's very easy to test a pilot. You can put them in a simulated 747 with 2 engines out on an icy runway at night in the rain and see if they can land the aircraft with a 15-knot tailwind. And they were as good of pilots as anybody in the world. So 4 years this went on. Finally, a small subsidiary of Boeing put observers in the cockpit to watch what was happening. And what they saw was that when the captain was flying the airplane and making mistakes, the first officer didn't say anything. And the Koreans had imported Confucianism into the cockpit. And in the Confucian system of thinking, it's forbidden to correct or criticize seniors. Also, there was a big rank differential. The Korean Airlines pilots had been trained in the military in those days. And so what they saw was that when the captain started to make mistakes and the first officer had a hard time ignoring them, the first officer would even read a magazine while they're flying along. Big jets are all designed to be flown by 2 people working together, and that's what broke down. The fix was really interesting. The company Boeing went to Korean Airlines and said, we have to get the Confucianism out of the cockpit. It's so rampant in your culture that the only way we can do this is to let them only speak English. So you must get rid of every crew member that's not fluent in English and replace them with English speakers. And by the way, all air traffic communications worldwide are in English. And so by making them speak English and then teaching them interpersonal management skills to make a partnership, a safe flight was immediately restored. Again, fifth force trumped individual abilities is our core message. I can go on and on with these. It just never stops. Here's another one that's kind of fun. An experiment was done in the 50s where cards were shown to a person who was a subject in the experiment. When 7 people in front of them intentionally gave the wrong answer, for example, they said, the question was, which line is closest in length to the line on the left? When 7 people said line B, when it's obvious any child could see it's line C, 1/3 of us gave the wrong answer. This fascinated me because I wondered why this was and thought for years people were intentionally giving the wrong answer because they wanted to fit in. It turns out, using MRI studies, that in fact that's not the case, that there was no active functioning in the decision-making region of the brain, so people thought they were giving the right answer. This is how powerfully the fifth force can change perception. Another aircraft accident, Tenerife Island, 583 people killed. The 747 was captained by the Captain Van Zanten, the most well-known and famous pilot for KLM. He was the head of training. They're on a foggy runway. They were diverted from Madrid because of a bomb scare. A garbled radio communication comes through. He spools up the engines for takeoff. The junior officer says, "Excuse me, Captain, I didn't hear a clearance in that." The guy kind of scowls, pulls the throttles back. Second garbled radio communication comes. Captain spools up the engines again. First officer doesn't want to be embarrassed again. Says nothing. They go down the runway and plow into a Pan Am 747 sitting on the runway. Tokyo 2005, the interesting story here. When you make a serious mistake in the Tokyo train system, you're sent off to an embarrassing and humiliating school. The guy driving the train had been in that school before. He comes into a station. He misses the stop by 100 meters, and he's now fearful that the conductor is going to report him and send him back into this embarrassing social situation. So he waits for the conductor to make his report. The conductor phones in and said, "We missed the station by 8 meters. Turns out if you miss it by 10 meters, that's enough that you go to this embarrassing school where it's called rehabilitation, but you may just sand track by hand for a month." So the conductor phones in the answer the guy wants, no problem. He backs the train up, people get on and off, and he starts again. Well, half the population of Japan rides a train on a workday in Japan. And the stations have very short times to change trains, sometimes like 20, 30 seconds. So he sees that he's a minute and a half late. He's got to make up the time. He speeds the train up to top speed, 126 kilometers an hour. He comes into a curve and sees a speed limit of 70. Well, he's got a choice here. He can hit the emergency brake, which would stop the train in time. But if you hit the emergency brake, you go to this embarrassing school. So he decides to use the service brake instead. Doesn't slow the train down enough. It derails and kills 106 people. How about a simple example in everyday life? No matter how good an individual driver you are, if you text while you're driving, your probability of an accident goes up very, very much. I'll share with you some of the places I got insights from about this. There's a book called Training 8 Performance, put out by the ASTD Press, and the whole book is about how consultants erroneously do training when context is the problem. I have a fun story in there about a restaurant making toast. The waiters aren't doing it well. He hires consultants to train the waiters. They say, no, let's look at the context. They find out that it's all a context problem. They had too many roles for the waiters, more than anyone could do, and the toast stations were not up to date. Malcolm Gladwell wrote 3 books that are very well known, and he gave him the wrong answer. He should have called them Power of Context 1, 2, and 3. And he says, for example, if Bill Gates, in Outliers, he said if Bill Gates had been born 5 years earlier or 5 years later, we never would have heard of him. And he also analyzed the 75 richest people in all history, and several of them in the U.S. came from the Industrial Revolution. And he says if these people, again, had been born 5 years earlier or later, you never would have heard of them. In my own experience, those of us that worked at NASA during Apollo are very different than people who didn't. That context shaped us forever. These are all examples of troubles. How about a good one? Well, I put together the mission that that successfully repaired Hubble, and I like this quote: "There are no great men, just great challenges that ordinary men out of necessity are forced by circumstances to meet." So I view my role in putting the servicing mission together as something very ordinary, and by now I'm slowly understanding this notion of the context. I think it's a fair question, since I ran the Hubble team for 8 years before the mirror flaw, why didn't I change the context someplace along the way? Well, I think there's several good reasons. One is, when I got that job, I was 38 years old. I had no experience running programs, big programs like that. I had no idea how it was done. Secondly, all NASA management around me and above me modeled this criticism model. Even the administrator at the time, Jim Beggs, we got in his NASA jet and we flew around the country criticizing contractors. And finally, when I joined the Hubble team, we were in our 5th year, and I didn't, at that time, the sort of context and culture was pretty well set, a very big program, hard to change. So now comes the servicing mission, and at this time, nobody wants to be associated with Hubble. So I'm beginning to catch on to this little by little. So I set up first a 4-dimensional, not exactly, but pretty close, 4-dimensional high-performance context. I got people to come by appreciating them. I said, you're the best person in the world to fix Hubble. Would you please come help me? Then I spoke to my inclusion. You will be granted all the authority you need to do your job. I will not micromanage you. Then the commitment, I said, not only am I 100% committed to fixing Hubble, I'll remove anybody from this team who's not also 100% committed. And then finally, in the request or direction, I said, would you please come work with me to get this mess cleaned up? And so this continued that sort of high-performance green social context throughout the life of the mission, and it was entirely successful despite being far, far more difficult than the original Hubble development was. So unbelievably today, Hubble is in its 20th, more than 20 years of successful science with 10,000 publications, something that was unimaginable in the middle of the mirror flaw time. That wraps up the fifth force piece, and we will stop here and then go back to how we manage the fifth force, starting with seeing invisible fields. Thank you for listening, and see you in the next segment. Bye-bye.